All right, let's talk about quadratics and intercept form. So we've talked about standard form and we've talked about vertex form, and so now intercept form. So there are at least three forms for quadratics. Now remember, quadratics graph to be parabolas, like a happy face or a frown face, but you have three different forms: standard form, vertex form, and now intercept form. So intercept form is when you have it in the form of x-intercepts. So consider an equation like this: f of x equals 2 times x plus 1 times x minus 3. So what you want to do is realize that these are going to be x-intercepts. And when you have x plus 1, you want to think of the x-intercept as -1. So I'm going to use -1. And then x minus 3 means you're going to have an x-intercept of 3. So what you want to do is use those 2 points as x-intercepts, and you want to graph those on the graph. So here's x equals -1 because that was x plus 1. X plus 1 means you're going to have an x-intercept of -1. -1 is what you put here to add to 1 to get 0 there. And +3 is what you put here to subtract from 3 to get 0. So we have two x-intercepts. I've plotted them here: an x-intercept here at -1 and an x-intercept here of +3. So what you want to do, though, is you want to find the midpoint between those 2 points, because that's where your vertex is going to be. And the vertex is arguably the most important point on a parabola, because it's going to be the lowest point or the highest point. So it's very important. It's the most important point. So to find that, you use the -1 here and the 3 there, and you add them and divide by 2, because that's going to be the midway point between those x-intercepts. The midway point, the midpoint between the points, is where the vertex is. So -1 plus 3 added together would be 2, and 2 divided by 2 is 1. So what that tells me is that the midpoint between those x-intercepts is 1. So look at what I did down here on the graph. I plotted -1 from here and +3 from there, and then this axis of symmetry that I've drawn down the middle hits at 1, because the midway point between these 2 points is at 1, because you've got 2 spaces here and 2 spaces there. So you can find the midpoint by adding these together and dividing by 2. -1 plus 3 added together divided by 2 is 1. And so this is called an axis of symmetry. So this little dotted line that I've drawn there is an axis of symmetry. And a lot of times they'll ask you in the book or on a test to label the axis of symmetry. So you draw a little dotted line right down the middle, and right beside it you put something like x equals 1. I'm going to do that. Let me grab my pen here. So I would do it like this. I would say this is the AOS, the axis of symmetry, and I'm going to say x equals 1. Now, if you're looking for a great place to mess up, here is one of the best. Like all my years of teaching students, even after I would say this, I would write it on the board, we'd do a bunch of examples, they would still say the axis of symmetry is 1. Well, the axis of symmetry is not 1. 1 is the answer to a question. If somebody asks you how many hot dogs you want, I want 1. But if what you want is an axis of symmetry, which is a line about which the graph is symmetrical, then you don't say it's 1, you say it's x equals 1. And trust me, that's huge. There's a huge difference between 1 and x equals 1. So it is a vertical line. X equals 1. That's the axis of symmetry. So you see how I labeled that? Now, to get this vertex point down here, the y value, we found out that the x value was 1 by finding the midpoint between these 2. Then what you want to do to find the y value is take that 1 and plug it in up here. So notice I did that over here. So 2 times 1 plus 1, because I've substituted the 1 in there and there. So 2 times 1 plus 1 times 1 minus 3 equals 2 times 2 times negative 2. Well, that's negative 8 when you multiply all three of those together, negative 8. So x equals 1 and negative 8, the ordered pair 1, negative 8, is the vertex for this. So a lot of times they will ask you, what is the min or the max for this quadratic, for this parabola? And what you would say is this is a min because it's a low point. It's the min, the minimum. So the minimum point is negative 8, and where that occurs is x equals 1. So the ordered pair 1, negative 8 is said to be the minimum. And technically, the minimum is negative 8. It's the y portion of the vertex. And where that minimum occurs, that minimum of negative 8, where that occurs is at x equals 1. So a lot of times they ask you to label the vertex. Let me do that too here. I'll label the vertex. So this is the vertex down here, and that is 1 and negative 8. So that is the vertex. So when you're labeling, when you're graphing these and labeling, that's what you want to do. Something like that. So notice how I have it's symmetrical about this line. And the vertex is 1, negative 8, and the axis of symmetry is x equals 1. Maybe the other question they would ask you is, how does this compare to, say, the parent function of f of x equals x squared? Well, notice the 2 in this equation out here, which means it's a vertical stretch by a factor of 2. So this graph is a little thinner than the parent function f of x equals x squared. And usually that's about all they ask in an equation like this. So you're finding the axis of symmetry, you're labeling the two x-intercepts. That's enough to draw these points here and there. If you needed more points, or if your teacher wanted more points, you can make a table of values, or a lot of you are able to use a graphing calculator in your class. Perhaps you would type this into your y sub 1 equals and graph it, and then hit second and table and look at the table of values. You could plot more points than this if your teacher required it, but this would be adequate for me because I can tell what the graph looks like just from that. But there's no problem with plotting more points along the way. So you could plot some more points this way, up this way, or this way. You could do that. It wouldn't be a horrible thing, but it's not necessary. See ya.